Hello, everyone. Welcome to this week's episode of FireDEV, a fireside chat with people in the industry. Today, my guest is Bjarne Stroustrup. Bjarne, how are you doing?
I'm doing fine, thank you. It's a beautiful day here in New York.
And I think everyone knows, who you are, Bjarne. That's listening to the podcast. You're the creator of C++. Um, but before we, get into any of, that side of things, I always like to, go right back, look at your education because you've been around in the industry, for a little while. So, where did you get your start in terms of, computer science and programming?
Um, I signed up at my local university in Aarhus for mathematics with datalogy, and I didn't quite know what datalogy was. I thought it was some kind of applied mathematics. It turned out to be computer science, and that was rather good because it turned out that I really liked programming and machine architecture and that kind of stuff.
So, round about when was this then?
That was in 69, 1969.
1969. So, just turning into the 70s. So, very early on. What did computers look like at that time? And what were the sort of languages that you was coding in? Because all the stories that I've heard of, not even that long ago, but still a while ago in terms of computers, it seems like just to use the computer, you had to be a programmer of sorts. It's not like now where if you are not a programmer, you can get a lot of use outside, from a technical device like a phone or a laptop or a computer. So I'm guessing it was a necessity to code. So what was the languages and what did the computers look like of, the late 60s, 70s?
Okay, I didn't actually get to uh, anywhere near a computer till 1970 because you had to take a year of pure and applied mathematics to get to there. And the machine was something called a gear machine, the Danish built machine for the Geological Institute. And as it was in those days, it sort of filled a fairly large room. And yes, the only thing you could do with it was to program it to do things. And I seem to remember it had one 1 kilobyte of 56-bit words as main memory, and then a slight extension of two more. Um, and I don't think it was megabytes. I think it really was kilobytes. Anyway, um, the language used was actually Algol 60. Um, they had what was the equivalent of a virtual memory, and they could swap things in and out very efficiently. And so Algol 60 was the language. And people who implemented that could write very tight code. The language, the full name was Gia Algol 60. And then um, later, in the later years, I learned Snowball and Assembler, of course, and even later a little bit of very early Simula. The Simula was invented in 67 and had the basics of object-oriented programming in it. Anybody who uses the word class for type can thank the designers of Simula because that's where that word came from. They were, of course, not computer scientists because that had barely been invented. They were mathematicians and they knew what classes were, not types. And it's also where we got object oriented design and object oriented class hierarchies from. So I got a variety of languages.
So when you first came across computers back then, what was your first sort of opinion of them? Was it like a wow moment where you just thought, okay, this is where it potentially could go, or was it okay, this is cool, I'm finding it fun and interesting. It sounds like you like maths as well, so it's like like a kind of a different extension to that. Which one was it? Was it the wow factor, or more, I just enjoy it, so I'm just gonna see where it goes?
More like, wow, you can do that? I want to try that. And didn't have much view beyond the courses I was taking. But this was sort of the very interesting course and a very hands on course. Mathematics is very abstract, um, especially pure math, and computing is much more concrete. If you make a mistake, you find out very quickly.
You do,
And
especially with the languages that you would have been dealing back then. You get a lot of loosely typed languages now, and the environments where it does a lot of like error and bug checking for you, and now mixing in with AI, even fixes things, even sometimes on the fly. But yeah, I'm guessing back then, any little error, it would just prevent you from running in probably any language back then.
I don't know. I mean, Alcohol 60 is certainly more tightly uh, checked than say C. And uh, Simula, which I learned in 71, 72, is fully type safe with static and dynamic checking.
No, no,
Uh,
yeah, that's what I mean. Like the languages back then, the ones you mentioned, like Algo 60, similar, and obviously, definitely assembler. There was little to no room for errors. Whereas languages today, if you let's say
ah,
you're going down like the JavaScript route, especially in a browser type environment, you can write code that technically, if it was written in the equivalent C++, just wouldn't run, but it'll run now, and it might even be okay. Like the browser, the environment might try and interpret what you're trying to do and kind of fix it on the fly. That's what I mean. Like it was, obviously even, more tight back then.
it was quite tight, especially Simula. But Simula did have the basics of object-oriented programming in it, so you could define your own types and you could have hierarchies of types and things like that. Um, but the modern languages in the modern world and the heavy use of tools and the humongous computers just wasn't there and didn't think much about it. Um, and if I wanted to do tricky things, there was always assembler. I made a living out of writing assembly code for a few years on the side of my studies, paid for my master's.
So, post, your degree with, mathematics with computer science, you came over to the UK where I'm based to study at University of Cambridge, doing a PhD in computer science. So clearly, you really got into the computer science side of things, pursued that further into a PhD. What was you doing during your PhD? Like, what was your thesis? What was you exploring? And why the UK? Obviously, University of Cambridge. It's a very prestigious university, one of the most prestigious in the country and the world. But why not the US, where you did eventually go and work for many years, and you're still there? So why come to the UK for your PhD? Was there something about the University of Cambridge that the other unis around the world didn't have?
Not really. I had an invitation from a professor at Queen Mary College to go and visit, and that was fine. And I sort of liked England, so I thought I would stay and applied for a PhD because that seemed to be a very simple way of staying. And got a choice of UK universities and picked Cambridge, uh, mainly because people told me that you didn't say no if you got an invitation to Cambridge. Otherwise, I might have chosen another one. The interview at Cambridge was probably the most grueling I'd ever had anywhere. That also influenced me. If they could do such a job, they must be good. It was Roger Needham and Maurice Wilkes doing a double interview of me. And halfway through, they told me that my ideas of what I wanted to do was not bright, was not going to be very successful. So could I do something else? And I sort of was a bit shocked and thought for a few seconds, well, I've been doing a lot of microprogramming and machine architecture. Are you interested in that? And since Maurice Wilkes had invented microprogramming more or less, and um, they've been doing a lot of work with um, operating systems and machine architectures. David Wheeler had built the first capability machine, hardware support for all of the good stuff we want. They thought that was a good area to work in. I got an offer, and when I went, I studied sort of let's say hardware support for higher level language construct, mostly to do with distributed computing. I wanted hardware support for communication channels, and that's where my PhD is. So I'm sort of a systems guy, um, as opposed to some people who think I'm a language lawyer, which I'm not, especially not the lawyer bit.
Okay, and you were saying that during your interview with these two guys, your ideas were effectively rejected. Like, what were those ideas
Well,
that
I
they
had
said weren't?
some ideas that was more general and involved a little bit to do with languages, which I've also done in back in Aarhus. Got my compilers and languages courses, just like my uh, machine architecture and such. And their opinion was that language PhDs usually fail. And I mean, everybody seems to want to build a language, and it's usually not a bright idea. I get asked ever so often by people who send me mail saying, I want to write this language, I want to build this language, how do I do it? And the answer that I give usually is why? Is this really a good idea? There's hundreds of languages designed every year, and they essentially all fail. What is the problem that you're trying to solve? And uh, that's sort of my attitude to that kind of research. And that, by the way, brings us um, to what I did later, because I got a problem for which there wasn't a language.
So what was that problem? And obviously, just piggybacking off what you were saying, yeah, and I know I've had those thoughts about, making a language. Had a few attempts over the years for one was like a hackathon, so that was more just, like I think like a 48 hour period of coding, and then just a couple of other looks at it as well. But yeah, you're right. Like, why do you really want to make a language? And could you just use an existing language and maybe make a framework for for that solution? And I feel like most of the time you can maybe make a specialized framework to solve what you're trying to do instead of trying to create a whole new language and all the other problems that comes with that in terms of the adoption and getting it onto the different platforms, the documentation testing, etc. So so obviously I'm guessing you're referring to obviously C++. What was the main problem you was trying to solve?
Yeah.
Because obviously it's known as the object oriented programming language, like extension of like the next almost version of C in a way. But then you said that Simula had object oriented design in it, so it wasn't the fact that an object oriented programming language didn't exist. So what was the main problem you were solving?
So um, first go back a little bit to what you said before. Yes, usually you can solve the problem by building a, library or de facto building a domain specific language embedded in a general purpose programming language. That solves most problems better than building a new language from scratch and has a much higher probability of success. So, since I'd been building in Cambridge, I'd been building, designing some facilities for a distributed system, and I had simulated such uh, systems and measured a little bit on it. Then, when I came to Bell Labs, where they had all kinds of good problems and good support tools and great people to work with, I decided I was going to build a distributed system. That's obvious. Most people coming out of their PhDs either loved what they did and want to carry on doing it. That was what I was, or they are disgusted and wants to do something completely different. But that's not something I know about. So I wanted to build a distributed system, and since I was at the computer science research lab in Murray Hill and Bell Labs, where Unix was born, and C, I wanted to build a distributed Unix. And if I'd succeeded, I would have built the first sort of Unix cluster at least 10 years earlier than they actually did happen. But for a huge variety of reasons, I couldn't do that. It's not a one person job for starters, and the skill set needed to do uh, distributed Unix is quite extensive. And I got plucked before I got to those problems. I couldn't find a language in which I could write this system. Um, at Cambridge, I'd had to stop using Simula for my simulations because it just wasn't fast enough. And so I used BCPL, which was very fast and could run on hardware where I didn't have to compete with the physicists and the chemists and the astronomers for time because it could run on experimental hardware. So I had sworn I would never again attack a problem with insufficient tools. And the tools I needed to build a distributed system at Bell Labs was something that could do low-level programming, like BCPL, and something that could do high-level programming, well, like Simula. The low-level stuff was things like device drivers, process schedulers, memory managers, that kind of stuff. Needs high performance and good access to hardware. And since I was in the same corridor as, say, Brian Kernighan and Dennis Ritchie, this was obvious to pick C because it was not only one of the best languages for this, it was also by far the best supported. But if you want a distributed system, you need much more control of locality, of modularity, and communication than you get from a low level language. You want to say there's a module over here and there's another module over there, and they communicate through this communication channel using this protocol. That's not low level stuff. That's high level stuff, and classes are ideal for that. And so I looked for a language that could do both, and didn't find it. And to this day, I think it didn't exist at the time. Most languages specializes in either being low level or high level, and the high level languages can be very pretty, but they must sort of outsource um, the, the, the sort of the low level dirty work. to something like C or C++. And I couldn't do that. There wasn't a lower level language to outsource to. So I took the class concept from Simula and built it into C. I couldn't go the other way because the Simula um, compiler and runtime system um, was too big and too expensive. And uh, though I considered putting in low level facilities, it doesn't quite work with a garbage collected language. And yeah, I couldn't afford to use Simula and I couldn't do the job in C. So we got C++ out of it.
Okay. So with C++, I correct me if I'm wrong, Bjorn. I think I heard you in a podcast or in a interview once saying C++ is not an object-oriented programming language. It happens to support classes as one of the design, ways of designing your code and writing code, and it happens to be the one that everyone or a lot of people use C++ for. Is that correct? Like your main purpose wasn't just to create an object-oriented programming language that happens to be one of the design patterns that can be used.
Um, to be more precise, I didn't actually want to design a programming language, let alone an object oriented one. I just wanted a tool to build my system. And it turned out that that tool was a language, and it turned out that I had a good background in education in both the hardware and in the languages and in the compiler techniques. So I could build a language to solve that problem. And I needed what's called object oriented programming for part of the job, but only for part of the job. So it was by no means an accident that C++ supports object oriented programming well, because I needed that and I wanted that and I knew how to do it. I mean, I knew Christian Nygaard and Ole Johan Dahl had used Simula, but that was only part of the job. Similarly, I knew Unix, I knew C, I knew Brian Kernighan, Dennis Ritchie, and people like that. And so I needed both. And a lot of people who were thinking about object oriented programming and such saw it as a bit of a religion. You have to be pure, you have to be only object oriented, everything has to be a class hierarchy or something like that. And I certainly did not think like that, not at all. Uh, I don't believe there's a single paradigm that is best for everything. I didn't think that then, and I don't think that now. You have to have a flexible tool, a general tool that can be applied and bent to the needs of a huge variety of people and a huge variety of problems. Um, at the time, I had a big problem, which was the distributed system. But then I also had colleagues. And when I built the early versions of C++ called C with classes, it turned out that it addressed more problems than just the ones I had. And of course, that's what you aim for if you do language design. If you do tool design, you really should build things that are more general, that can do things more than you can imagine. And I've done that. And so I slowly built up a group of people that used the language. No advertising, no hype. It just happened to fit many problems better than other languages at the time. And so I got more and more sucked into designing and building and teaching C++, as it was eventually called. And of course, I never got to build that distributed system that I was starting out to try to build. And in retrospect, it was perfectly obvious that I couldn't have done it. Not a one person job. And yeah, I didn't have a big organization, and no budget and such.
So, you're obviously talking about how, and I've come across this before, where you get people, and it's not just object oriented programming. I find developers in general, they can become very religious behind either a design pattern or a particular programming language, or even the type of programming you're doing. You'll be like, web only, or only game development, or none of that's pure unless it's just regular code in some sort of application on like a device, whether that's a phone or whether that's a computer. But yeah, I've seen all those things around object oriented programming, how people get very religious, and then on the flip side of, I'm not going to use any object oriented programming at all, I'm just going to use something else. Linking with that, what are the pros of using C++ in your eyes if you are not going to use object oriented programming? Would you still say C++ is a language you would recommend if somebody says, I do not need or want object oriented programming? Because I know people that go away from object oriented programming. I had a friend a few years ago, heavy into C++, great developer in C++, been around doing it for many years, and he kind of said, I'm not going to do C++ and object oriented programming anymore. And the first thing he did was switch to C. So is it a matter of there's no point using C++ anymore, or there's still so many other benefits to C++, even if you're not going OOP?
Now we have to dig into the definition of object oriented for a second. Um, the traditional definition of object oriented programming is there's encapsulation, there's class hierarchies, and there's classes. And I can see that some people will not want to have everything be a class hierarchy. Most of my code is use very limited class hierarchies. What I do use all the time is classes because I want my types, the types that fits my application. I do not want just the type that, say, Dennis Ritchie or I invented and built into the language. And I don't see dropping C++ um, just because you don't like class hierarchies. Um, do you want a complex number in C++? That's a class. Do you want a string in C++? We have a very good string class. Random numbers, threads, you name it. They are basically standalone classes that is a better solution to most programming than going straight down to structs and functions and function pointers, or sorry, pointers to functions. And the type checking is pretty good, and you can do things like overloading. Yeah, there's lots of facilities there that you can use even if you don't like class hierarchies.
Okay. And in terms of, C++, did you just create the original version, or did you contribute beyond that? Because if you look at, and we'll go into this in a second, but if you look at C++ now, with like the auto keyword, lambda expressions, range based loops, there's a lot of newer functionality. I want to dive into that as well, your opinions of those newer features, but putting them aside.
Let me directly comment on your examples. I was a major player in lambdas and the range 4, and uh, I am the one that introduced auto. And we can go to why that's necessary, but take the range 4. It's one of the things that allows you to say something terser and just as efficient as if you write it out in longhand, and there's a whole bunch of mistakes you can't make because you don't have a loop variable you can get wrong. So there we have a facility that takes care of somewhere up towards 90% of all the loops with no loss of efficiency, easier to write, and fewer opportunities for mistakes. Let's see. I started out with some very simple facilities and SQL classes, and um, I knew very well at the time that there was no way I could build my own ideal language. I would have to start small and then grow it. So C++ was designed from the very early days to evolve based on feedback. I mean, evolution based on feedback is the basis of all good engineering. You build the best you can, you put it into use, you see what works and doesn't, and improve it. And so I made implementation of SQL classes, and in that I built the first C++ compiler. And that first C++ compiler I then used to compile itself, having bootstrapped that way. And I was the developer and the maintainer of that compiler for another few years till somewhere in the region of 1988. Other people took over the maintenance, and other people started building their own compilers. About 91, there was at least a handful of C++ compilers, and so I did other things. And about that time, representatives of HP, IBM, and Sun came to my office and says that I really wanted to standardize C++ under the ISO rules, and that was news to me. Since I knew very little about standardization and ISO, but they pointed out to me that their companies were dependent on C++ and they couldn't be dependent on something that was controlled by some entity like AT&T. They very kindly said, of course, we'll trust you, and added, but you might get run over by a truck. So after about an hour of arm twisting, I agreed that I really, really wanted to standardize C++ under the rules of ISO, not knowing what that meant. Um, but it seemed necessary for the success of the language and for the success of my users, because they were my users, and so I owe them something. And so for the next 30 years, I've been working in the C++ Standards Committee, and a lot of the major improvements there comes from me and my friends working on similar topics.
Okay, so up to like, are you still actively part of the C++, development in terms of the newer features, or has that side stopped, and
Oh,
what's the
I'm
situation?
still active, quite active. I'll go to Poland in 2 weeks for a 1 week standards meeting, and I'll be um, presenting yet again some of my proposals for improving safety of C++.
Okay, so it's still something that you're heavily part of, and then
Yeah.
going off there, I mean, my question was going to be, do you use newer versions of C++? I'm guessing if you're still active in the development, there's no reason why you wouldn't use the newer versions. Is that correct? You're using the newer
Oh,
versions?
I was testing out a couple of features on newer compilers this morning, um, finding some strengths and some weaknesses on the Microsoft and the GCC latest versions.
Okay, so you're still, heavily into that. It's still part of it. It's not a matter of, I created the original version. I'm just gonna stick to that. I mean, that's good to hear that. You're obviously in with what is new and what is modern, and to have that context of, Bjarne Stroustrup, with the newer C++, I guess, to kind of make sure it doesn't deviate from its
Also,
original
also
path.
importantly, I'm not just doing that. Over the years, I've always either been part of development organizations, or I've been teaching it, or I have been collaborating with people doing interesting things with C++. You can't just get into a bubble of language enthusiasts, because language enthusiasts tend to, well, overrate languages. A language is part of your tool chain, it's part of the stuff you need to do to build a good system, but you have to understand the systems.
Yeah, need to see its actual use cases in industry and real, environments. I know what you mean, and now that we're talking about education, I think that's a problem with education as well. It's like when you get somebody that's just heavily in education or heavily just in R&D or creating tools, but then they don't
Mhm.
have the context of what is this actually being used for? What's the education going to lead to? What's the tools going to lead to in terms of the end applications or the end use cases? You just end up, like you said, in your own bubble. And I think, there's it's more true this way, but I feel like the other way as well. So if you're always just doing end, applications and updates on live applications, having no knowledge, and I feel like that's kind of a problem with a lot of developers nowadays. No fundamental computer science knowledge. They're sort of experience and what they can add to a project or long term can sometimes be lacking. So talking about your education, in terms of your education career, you're a professor at Columbia University. Is it safe to say that you teach C++, or do you teach computer science or something else?
Actually, I teach design. I have two
Okay.
courses, one that is software design and it's mostly based on C++, and the other one is sort of readings in language design, which reads classical papers and discuss them. Um, Let me just see. We've been doing uh, Scala, R, Haskell, Basic, Pascal, and Rust, and we'll be doing Icon, Basic, and Java garbage collector over the next weeks. Um,
So are these undergrads or are they like masters and PhD students?
Actually, they're about half and half. I try to have half and half last year, undergrads and then grad students, especially for the design course. That is really an advantage, I think. The, uh, the graduate students have more experience, and the undergrads um, have a very solid uh, computer science background. They're Columbia students after all, and putting them together in teams, you get really interesting results.
Okay, so going back to some of the more modern features of C++,
Oh,
and
one thing before we do that, I think we should point out that I have not always been a professor. I mean, first I was for a couple of decades at Bell Labs doing industrial research. Then I went 10 years to Texas as a traditional professor, graduating PhDs, applying um, for grants, teaching undergrads, teaching graduates, and such. And then I actually went to work for a bank in New York City. They had very interesting computer sciencey problems to do with communication, uh, mostly was what I was doing, and looking at large code bases. And then after retiring from there, Columbia snapped me up, so I'm now a professor again. And also throughout that time, to avoid the bubble effect you said, I tended to travel and visit people 5, 6 times a year, different organizations, usually each trip visiting more than one organization, and learning what their problems were and trying out my ideas to see if they addressed what they needed and whether they understood what I was saying. So that's a very active attempt over decades to avoid the bubble effect. One problem with professors is that their previous job usually was student, and a lot of professors, not all, but a lot, doesn't know the outside world, even though they might think they do. And as you pointed out, a lot of developers are in the bubble created by their current application or their current company or their current uh, application domain, and tend to be a bit intolerant of people with different needs. A lot of the problems we have with the reputation of C++ is that nobody needs all of that. Obviously, they don't. The problem is that when you have uh, probably about 7 million users, their needs vary dramatically, and we try and support them.
Yeah, that's definitely something over the years that I've thought about as well. Like, how do you prevent yourself from being in this bubble? And because sometimes you might get comfortable financially speaking, you might just genuinely enjoy what you're doing. Let's say, as a university professor or something in education, or actually working on end products. But you can start to get a bit style. One thing that I felt or found that helps, because obviously the sort of stuff you're talking about seem to be actual positions in actual organizations, and they may not be so easy to come across. It's doing your own thing. So like we're on this podcast on FireDEV, I'm talking to Bjarne on here. This is not my main day-to-day job. I'm a contract developer right now, doing a contract in like React Native, JavaScript, etc., and everything that comes along with those technologies. But this is a way of keeping it fresh, obviously meeting other people that you might be able to doing something else, for example. And it might be something else, it might be creating videos on YouTube, it might and you can still have a technical aspect to it. But yeah, there's several ways of getting that variety without having to be, go and be part of some other, organization. I think it's great if you can and if you want to go down that route, but I don't think it's, 100% required.
Yeah, I did a lot of that by traveling. It is
Mm.
very easy to be um, comfortable.
Yeah,
Um, it's not always nice to be facing the weaknesses of what you're doing and your own ignorance. It is much easier to do a project that's just like the previous one, and that's a danger.
it is. And like that's similar to the what you've done before. You can deliver. What your deliver will be, you know the people that you're delivering to, whether that's a client or whether that's a company, whether that's end users, or where even if that's for yourself, it can literally be you doing some personal project. But if you're not trying to do something different, break the mold, you kind of know that you're gonna succeed. Because if you're always making single page websites, and you're saying, I'm just gonna make another single page website, chances of you failing is highly unlikely. But if from that you say, okay, I'm going to now do some game development, and you've never done game development, for example, or if you haven't done it for a while, there's a lot of unknown to it, and you can create a lot of difficulty, and that can put a lot of people off.
I have a technical question. Is my voice being recorded?
Yes, it should be. I mean, your sound waves are coming up when you're speaking.
Well, it's not coming up on my computer.
We've had that issue in the past, so it shouldn't be a problem beyond, because it's coming up, and that
I can
should be.
see yours, but I can't see mine. So
Yeah,
I had to ask.
yeah, no, that's fine. Because what I've also found is sometimes they're appearing, but they're just so small, and for some reason the wave length,
Okay,
but they're still
if
okay.
you're comfortable, that's fine.
Yeah, no, again, I have no reason to doubt you, and it gives me, you know, errors. If there's anything wrong, there's nothing wrong on mine, so I'm happy with that. There's no issues. But so going back to those modern C++ features, if because obviously you use them, you're part of the development of some of them, or I'd love to go over them and see your thoughts and opinions. So going on range based for loops at university, I did C in first year, C++ in second and third year. We wasn't taught about range-based for loops. So when I actually came across it, it was post-university. We was just taught about, create a regular loop. You have, like an int I, you have a condition, you have something that, some line of code that runs at the end of it. Basically, you're setting it up yourself. And I saw all the problems that came along with that, accidental variable assignment, value assignment to the variable, all sorts of other things, especially when you are just trying to go over some collection of data. When you teach it, or if somebody is learning, would you recommend them learning a range based for loop as the first time of using a loop like this to go over a collection of data? Would you say leave that until you're comfortable with the concept and you can implement a regular vanilla for loop?
I would use a range for loop, and I see that as the vanilla loop.
Okay.
For all elements in this container, do this in order from the beginning to the end. What can be simpler than that? Now, if you want to do something more fiddly, more difficult, I'll teach you another way, another loop that is a bit more complicated, but you can do things like looking at every second element, or um, iterate with, say, a Fibonacci series as your indices. I was doing that this morning just for fun.
Okay. So
Um, you start with the clean, the simple, and then you go to the um, more fiddly and quite often older stuff. I mean, take the goto that people talk about a lot. I mean, goto can do anything. That's why we don't use it much. You use a cleaner loop structure until you are absolutely kicked not to do that. And for gotos, that's not every year. For a range for loop, it's probably everybody gets to it in a month or so. But I try to teach from a high level towards a low level. So I have a textbook called Programming Principles and Practice using C++, and it takes that approach. We use vectors and strings from day one, and range fours, I think, something like on day two.
your
And
approach
key
is high.
style strings and arrays comes much later. I think chapter 17 or thereabouts.
Yeah, because the way I was taught, it was more low to high level. So we was doing like a C, then we moved on to C++. We did a bit of C sharp and Java as well, and then some of the features that
A, a
came
lot of
along with those languages.
a lot of people are taught that way. In other words, they're taught all the bad manners first,
Mhm.
and they're taught all the horrible mistakes first, and then they later get are exposed to better ways of doing the 90 or 95% of the stuff. And I think that's wrong. It gives them a hard time early on, and actually worse, a lot of people don't get any further. Um, the usual definition of normal is what you experienced when you first experienced it. And so for kids, normal means what they saw with their parents and the early days of school. And so you have a lot of people who think that C is natural, and C's problems are the way things are. By the way, the C that people use today is to a very large extent my C. I defined the rules for function argument checking. Uh, in modern C++, you could declare the arguments and have them checked. And function declaration syntax and the function definition syntax is my handiwork. It looked different. Look at KNRC, it's different in the first edition. The second edition of KNR was written in C++.
So, so did you say not C plus plus? C. A lot of the ways people use it is more what you added to the programming world. Then is that
That's right.
correct?
Roughly anything you do with a function.
Okay, so that's your handiwork, whether it's directly
And
on C plus plus or in another language.
const, but they sort of got it wrong.
Okay, so dive into that a bit. The who got it wrong, just developers in general, and what
The
have it.
C Standards Committee.
Okay, so what did they do to get it wrong, and what's the right way?
They made sure that that const variables were local to a compilation unit, and that meant that you can't use them very well for constants, and so they are not anywhere near as useful as they are in C++.
Okay, so that's not the way you intended them for them to
No,
be used.
and they will of course claim that theirs were an improvement, but I disagree.
Okay.
But the point is, I actually had significant impact on C, and curiously enough, these C++ wars are not among uh, the the principals here. I mean, I talk to Brian Kernighan maybe every 2 weeks or so, and had lunch with him and Dennis Ritchie most days for 16 years. Uh, we didn't fight. Dennis helped me a bit with some of my things in C++. I had influence on C. It's these sort of semi-religious wars among programming languages are just so tedious and pointless. I have very few problems with people who really works at the high level of designing and implementing languages.
Okay, so because I know a lot of people that are very low level in terms of either their work or their preference in languages and technologies, they look down on the people that are just generally doing using high level technologies. So you don't have any issue with that if you feel like the job is better suited with a higher level language or framework. You're happy to use that. You're not defaulting on C or C++.
Oh, of course. I mean, I know what they meant. When I was writing microcode, I had a slogan that says as simple as for wimps. I mean, if you need a simply code, you're not doing real programming, right? Um, that was mostly a joke, even in those days, but there's the microcode, and then there's a simpler, and then there's a C BCPL level, and then there are other levels. C++ has several levels in it, and it's very good at collapsing those levels. If I was going to write, um, say, a device driver for a very small system, or say the programming for a power supply, I would use C++. It's just better at it than raw C. And the type system is part of it. The ability to define your own types uh, and encapsulate a state is very good. And the compile time evaluation that you can do in C++ is just better. And by the way, the power supply example wasn't artificial. I met somebody who were programming power supplies, the ones that sort of lies on the floor next to your laptop.
Okay. Um, so with the auto keyword, going on to that, like, you're saying that's something that you use. Like, what's the pros in your opinion of using that versus being explicit, versus saying this is an integer, this is a boolean, this is a string, etc. And you, like, again, going back to the educational example, do you recommend teaching, or it sounds like you probably will, teaching auto, or would you change your mind with this and teach using explicit data types first and then the auto keyword? Like, what are the main use cases of auto in your eyes?
There's two real uses of auto. The one is to stop repetition. There is a lot of code that says, here's the type, that's the variable, and here's the initializer. And you're actually saying the type twice. Sometimes you're actually explicitly saying the type twice. I mean, um, you say you have a yeah, say you're using a new expression. You would say something like foobar star p equals new foobar, and you're saying foobar twice. That if that's what you're doing, you're just repeating yourself. And if you are so that I wanted to eliminate back in '81, I think, and I put auto into CV classes. And well, I didn't get away with that. The Unix room didn't like it, and I backed off. But it came back when I got a second use case for it, which is in generic code. Sometimes the types in generic code becomes rather large. So if you have a vector and you have an iterator to a vector like begin, the code will be something like vector of foobar colon colon iterator equals begin. And I use auto there because I know what comes out of begin, and so does the compiler. And so if I want to write a traditional loop with um, with over a vector, it will be auto p equals begin uh, semicolon p not equals v dot end and then plus plus p. And of course, you can do that even better. You just use a range for loop, um, and you don't have to mention the iterator. But there, in many cases in generic programming, you uh, you don't really want to write those long words, and sometimes you can't remember them. Um, that can obscure what you're doing, and this is one of the reasons we have concepts for expressing constraints on generic types like auto and template parameters.
So obviously, in that example, foobar, star, p equals new foobar. I understand there. Just on that line of code, it is visually obvious what the data type is, and like there's two instances that it's mentioned. So the auto keyword, I understand what you're saying there, but what about on a simple line of code like int x equals 10? And obviously it's a integer, one because you put the data type before the variable name, but two because the data that you assign in is an integer, aka 10. Would you still recommend the use of auto keyword for that? Would you say auto x equals 10, or would you say that's overkill and that's not what you would recommend auto for?
I mean, I could do that, but I'm not recommending auto for that. Um, I tend to use int. Uh, I tend to use auto when it's not blatantly obvious what the type is, because then I can't get a surprising conversion.
Mm.
So I can't write int x equals a call to foobar, and having forgotten that foobar returns a double, and so I could uh, um, get truncation. So if I don't really know what comes out of it, I either have to look it up and get the type right, or I have to write auto because then I don't get conversions.
Yeah, then there definitely is that. Obviously, with all this problems around conversions, the data might not end up the way you would like it to be once it's converted.
Exactly. I mean, int x equals 7.2, or even better, 7.9. You get 7 in both cases.
Yeah, and obviously, I guess when you're coming from, yeah, I remember that example in programming, and it's something that when you're writing loads of lines of code, you're coming from the mindset of mathematics, bid math, bod math, ped math, whatever whatever term you've learned, and how rounding and everything works in um, mathematics. When you start coding and you start doing something around rounding or maybe operations, and you just think, why isn't it getting the result that you expect? And obviously it is due to these conversions.
Yeah. And basically, the data, basic data types in C is one of the early examples of generic code. You write code, it works for integers, it works for shorts, it works for doubles and long doubles, but it doesn't work quite the same for each of them. And so some flexibility is needed. And so you go into when you build your own types like complex and later with templates and such, you need something that can take the kind of type that comes out of a complicated expression and get the right type of it. And I know that you can have problems with generic types and you can have problems with specific types. I think using the more generic versions like auto helps more than people trying to get the specific types right all the time.
So I mean, that's interesting. We was talking about 7.2. Obviously that gets rounded down to 7. That makes a bit more sense. Then you do 7.9, you would expect it to be 8 if it's going to be in an integer, but it gets rounded or gets truncated to 7. Why is that, and why did you leave that as it is in C++? Why not be, especially considering you come from a mathematical background as well, why not make it the way mathematics would dictate,
Yeah,
round it up?
yeah. Um, I mean, a couple of reasons. One thing I realized early on was that I was living in a world with different languages,
Mhm.
C, Assembler, and Fortran in particular, and of course Unix Shell. And departing too much from those languages was dangerous. You could lose users. You could people could get disappointed by making the wrong assumptions. So I decided for compatibility with C. I'm not actually, in retrospect, sure that I could have done anything else. But I was at the time saying, you have a choice. You can get my mistakes or you can get Dennis's mistakes. I'm not sure my mistakes are less than Dennis's, and anyway, we know Dennis's. So let's stick to what C does.
Okay, so it was a matter of keeping it consistent, because obviously it's that thing, if you have C code you can put it into C++, even if it's not directly copy and paste. You might need to change the syntax slightly in certain languages, knowing that okay, certain things have a
Most of it for C, you don't have to change anything.
no, I'm not talking about C. I'm talking.
Yeah.
I mean, like if you take it in, let's say, into JavaScript or something else. But fundamentally, you want it to work the same way. So like yes, if you do something basic, it basically should output the same thing.
I'm reluctant to generalize this much because different languages have very different rules.
Hmm.
It was a simpler world then.
But back then, that was your thinking behind it.
My thinking was that you should, unless you have a good reason, you should leave good enough alone. You should allow people to do what they're familiar with because they think familiar is simple and because it saves complexity of the tools and being able to read a piece of code, not knowing whether it's C or C++ and have it had the same meaning, is good. It's fundamentally good.
Did you ever think about adding a functionality to make it more strict mathematically? So, like a compiler flag, strict mathematics, strict math, and it would be the way, mathematically it should be. So, not by default, but if somebody wanted it, they could. Was that ever something on your mind?
Yeah, but I backed off that. For starters, there's too many tools, too many compilers, too many linkers. Um, if Yeah, I thought it unmanageable. What I provide is facilities um, for writing code that doesn't have the problem. If you
Okay.
use curly brace initializers in C++, it will not truncate, it will reject the code.
Okay. So it's about providing good technologies and and a good feature set fundamentally than trying to rewrite how, languages generically output
Yeah,
certain data.
that's right. And people always say, why don't you give me a flag that bans all the kind of code I don't like? And my answer is that the code you like tend to depend on the code you don't like. So the only real way we can give you what you want is to provide first an extension that gives you the library facilities that you need, and then we can ban the lower level stuff. That's the basic idea of what's called the core C++ core guidelines that I've been working on for some years, and of the profiles that I'm arguing for in the C++ standards committee.
Yeah, plus, what you like and what you don't like will be heavily based on what and how you was taught, as well.
And
So
what you're doing,
yes, what you was doing, and I'm sure that'll be very different if you was taught in an academic setting, so like via a degree, versus on the job.
maybe. My main example is the C pointer. It points to either nothing or one, two, or many elements. And I mean, you can't range check it because the information isn't there. So, one of the first things you want to do to get better code is actually not to use pointers that you subscript. But of course, to implement something that can check, like a vector, you need the low level facility of pointers into arrays that are inherently uncheckable. But if you only use it through something that has the checks, it becomes fine.
Yeah, of course. And in the early days, after you made C++, you're using it for your uses. What were the first main users and adopters of C++, and how did you kind of, give it to them?
Actually, the first user was a researcher at Bell Labs who were studying how error conditions happened in networking um, under saturation situations. And well, came into my office, says, can I have a compiler? And says, sure, here it is. There, we shared a file system, so it was easy enough to give it. Later, I had to distribute it with Mac tapes because the web wasn't really there. But it was basically people come and they ask. Sometimes they ask for a compiler. Sometimes they ask for one of the early libraries. Sometimes they ask for new language features. Sometimes they ask for a little bit of teaching and support. And I was providing all of those for many years.
So was it from like the beginning that C++ just took off, that everyone just wanted it, they started adopting it, or was it like at a particular date, like 10 years later, where a huge use case and then everyone like, because by the time I went to university and I started coming across it, it was like one of the technologies to use.
No, there was no one particular day it came. Obviously, at some point, I had a shipping version that went out in the world sort of semi-standard. That is because I didn't make us. They didn't get the latest version, all of them. That would mean I wouldn't be able to know which version they were having problems with. So I had to do basically a release, and that gave some more users. And eventually, AT&T agreed on shipping it. Um, there wasn't free software in those days, but it cost $75 because that was the cost of making and shipping the Mac tape. Um, but it grew. I could keep track of the number of users for some years. Not perfectly, it's really, really hard to count users, but it appears that throughout the 80s, it grew, doubled every 7.5 months. And it was a fairly smooth exponential. There was not a single date or single release and such that did it. And then I sort of lost the ability to track it in the 90s, but it kept growing. I have some papers that I wrote for the History of Programming Languages conference that documents what I'm saying.
So the language was essentially used distributing it for free. It just, I guess, the means of getting it, the end user had to pay for. So like the postage, packaging, and I guess the production of the format. Obviously that was like a must. Otherwise, it would be costing money every single time. Then there wasn't the internet the way it is now, where you can just upload something, somebody can just download it a million times,
Yeah.
and it doesn't really cost you anything. So did you work on C++ when you was at AT&T Labs? Not time wise, I mean, actually, was it an AT&T Labs project?
It was a project at Bell Labs,
Now Labs, yeah, sorry.
and it wasn't really a project for many years. Some AT&T managers didn't like it because it competed with their product, which was C, and showed up some of the weaknesses of C. I mean, it didn't bother Dennis Ritchie much, but it bothers the managers. And I remember about three times where the C++ project was deemed cancelled by some manager. And each time they found out there wasn't any C++ project, so they couldn't cancel it. And it was just me and sometimes with the help of some friends. And each time we sort of uh, returned the compliment to the manager and forced him to support us better because he depended on it. Otherwise, he wouldn't have complained.
Yeah, no, I mean, that's always an issue when you do make something so good. It's funny that it wasn't even Dennis that had an issue with it. The actual, you know,
Dennis was a really nice guy.
it was the managers of the technology. Then I'm guessing some of those managers weren't even technical. They didn't even understand. I'm assuming.
I don't know. They were not Bell Labs technical management. I remember one Saturday I had the head of Bell Labs on the phone, wanting to know what these managers over on AT&T was complaining about. And I explained it, and he sent me a 5 kilogram chocolate bar as thanks.
So,
Bell Labs management was very supportive.
okay.
And by the way, it was not free for commercial use, so actually AT&T did sort of block some of its spread. It's not just that we didn't have marketing and that kind of stuff. We actually had a company that wasn't all that supportive, though Bell Labs, as opposed to AT&T, was very supportive.
So obviously, if you developed it at Bell Labs, which is what AT&T now, what's the ownership situation? Like, does AT&T technically own the original version or versions of C++, or what's the situation there?
I'm
Because I've
sure
never.
they own, I'm sure they own the original software, which has been outdated for 30 years. They did, however, give the rights to the specification to the ISO. And so, if anybody owns it, eventually it's the United Nations,
Okay, yeah, because I never.
which sort of controls the ISO. And also, in those days, it was not at all obvious that you could um, that you could own a language specification, as opposed to a compiler.
So what was the logic in that? Like,
What?
that.
Oh, it's I'm not a lawyer, and it's very complicated. But basically, sometime back when they invented patents and copyrights and such, somebody decided you couldn't own a mathematical formula.
Yeah.
I mean, you can't sort of go and patent uh, Pythagoras' theorem or something like that. And somebody decided that language specifications were like mathematical theorems, and therefore you couldn't patent them. Now, we know that Sun tried to do that, and it spent 10 years in the Supreme Court. But I think they lost. I don't know how much they lost. But no, it's hard to own a language.
Yeah, okay, no, I understand that logic. I know algorithms, if they meet certain criteria, they can be patented. So, like, that's something I've thought about before. If Pythagoras theorem or trigonometry or anything, let's say core mathematical was invented or discovered today, how much of that, if it was discovered in like some sort of Google lab or Microsoft lab, would be secured and patented and protected, because algorithms can be.
Also, depends on which country you're in.
Yes.
Laws differ. Um, I would rather not go there because it's outside my expertise, and I'll try and dodge whatever trouble that kind of people will make for me. Have you noticed you're not writing C++ TM?
Can you expand on that? I'm not 100% sure what.
Okay, registered trademark or trademark. If you look at Java, that there's very often a TM on it because they have patented the name.
Okay.
It's a trademark. Sorry, it's not a patent. It's a trademark. Well, of course, AT&T wanted to trademark C++, in which case we would have written C++ open paren TM close paren. And I thought this was just too ugly for words. And somehow or other managed to talk them into not doing it.
Okay, yeah. I mean, I had never noticed before that it doesn't have the trademark, TM on there, but just googling Java does. Again, it wasn't something that I had ever paid attention to. I mean, I think with Java you have the direct association with Oracle. I feel like more people directly associate Java with Oracle Corporation than C++ plus plus with Bell. I mean, in terms of the knowledge, it's just like C++ plus plus is kind of just there, if you know what I mean. It feels
Yeah,
like
I mean, this doesn't happen by accident. Somebody did pay attention. Me and a couple of friends. There is a danger, of course. People can go and build a totally different language or similar language but different, and call it C++ and try and get away with it. Some people have tried that and failed because people like the C++ to be what the committee decided it is, and it's an open committee. You can join it.
so you don't regret that decision of trying, preventing it from being trademarked like Java
No,
was.
no, no. Just like I've so often had to say, no, I don't really want to start a company. I don't believe fundamental technology is particularly profitable. And if I was the head of a C++ company selling C++ compilers, I would have to wear a suit and listen to my whoever was paying me for my product. That's not a good situation for a designer.
No, it definitely will does stifle innovation, and it it basically, I guess, kind of creates a conflict of interest because you're in sell mode, and what are you selling? If you're selling a particular product, you might not be, and I'm guessing that's probably the problem with some of the managers that you referred to earlier that didn't like the idea of C++. If they were so embedded in the world of C and its success, anything that was threatening that either felt like or was a threat to their career and their existence. Whereas if
Exactly. And if you are a small company and you're out selling, which happens to a fair number of languages, the head of that company, the original creator of the tools, has to become a salesman, and you can only sell what's fashionable. So you
mm,
have to follow fashion. And I don't like every fashion. Like in the early to mid 90s, everything had to be class hierarchies and you had to be pure as opposed to hybrid, as they called C++ as a insult. I actually took it as a compliment. But I would have had to follow some of these fashions if I had been the head of a small company trying to sell compilers and libraries. And I decided against it.
so that was you chose a slightly, obviously different path. So, talking about, you know, development, what's your development environment look like? What's your go-to environment instead of, in terms of IDE tools? Is it basic, or do you like to leverage all the latest tools like Visual Studio Code with all the plugins, potentially incorporating AI into it as well now?
I'm fairly low in terms of tool use. I like my code to run on at least the three main C++ compilers. Um, I tend to do my experiments with small examples on the Microsoft compiler on Visual Studio, mainly because of my friend Gabby Dos Reyes that I worked with in Texas and before, who's one of their main uh, people with the C++ compiler. So currently it is the most conformant compiler you can get for things like concepts and modules and such. And then I also use Clang and GCC. When I was at the bank, I did all my real development on GCC and actually Red Hat. But if you
So,
are very keen on portability, then you more or less by necessity become a relative low tool user.
Yeah, I can see that point of view because obviously, if you are bogged down to certain tools, some of them may be OS specific. Possibly some of them might not be the best for certain languages or certain use cases. So yeah, if you are using a lot of them, I mean, what's your stance on stuff like IntelliSense? I know some people very old school. They'll just use a text editor and then they'll write a bunch of code, compile it, then they'll see all the errors. Or do you like to kind of see it as you're going along, highlighted?
I I use several compilers, and when I was still in industry, I tended to use whichever tool set the team I was working with were using. And that varied, and it may very well not be my favorite, but it's not my job to tell everybody to do things the way I want them. And that attitude comes uh, through today, though it has fewer outlets now. Um, I for IntelliSense, I guess I use it, but not very much. The thing I like best with Visual Studio is simply the ability to flip around with files and have it tell me where that function is stored and go to the definition and that kind of stuff. I appreciate a lot. But I also write code on on sort of for GCC, which is often a variant of VI, which feels very different.
So earlier on, you mentioned that you worked at a bank. I don't think you specifically mentioned you was Morgan Stanley, but I can see that on your LinkedIn page. And banks and institutions, traditional institutions like banks, they have a reputation of being a bit sort of up themselves or stodgy in terms of innovation. Like, what was the innovation like in terms of soft? Because you was on the software side,
The,
the
the first the first thing was when as I said, I was traveling around talking to people in different industries, and that included finance. And when they first suggested I should come and work for them, my reaction was instant and very surprised. But you're a bank. Very surprised. It took them 3 months to convince me that one, they had problems that were interesting to solve, and two, they had nice people. And in retrospect, they kept every promise they made. So, whatever opinion I have, I can't complain. And by and large, I enjoyed it. Yes, there are areas that are very stodgy, and yes, there's areas that are uh, behind, and yes, it's really hard to get novel things deployed. And that's not unique to banks or Morgan Stanley. They have areas that are very keen on using the latest because they are competing with the rest of the world. And so sometimes I was frustrated, and sometimes some of my ideas went through and proved themselves. So, yeah, that's not that difficult. I mean, try something that's stodgy. You could try some academia. Try and change something in the curriculum. That's very hard. Takes
uh,
years.
I
It's not
know what
unique.
you're.
It's not unique to industry. It's not unique to banks. You always have to worm your way through the maze, as it were.
Yeah, the problem I think like with something like Morgan Stanley, there's two aspects to it. One, they're a large organization with potentially a lot of established users, and you get that issue with at companies like Google and Microsoft and any other big company. They can't change things too quickly because they always risk, you know,
Yeah,
making the wrong decision, potentially losing a lot of users. Companies have died literally from trying to do things too fast when they were no longer a startup. And then obviously with banking, if you're dealing with money and financial transactions, I guess if that's the last thing you want to do is
yeah. And
suddenly
there's a
make.
lot of law. There's a lot of laws involved.
Yes.
I mean, it's not legal to drop say, a payment into your bank account. It will be big trouble. And then I believe that Morgan Stanley operated in 40 different countries, some number like that. Every country has a regulatory framework and they all differ. Makes it difficult. And sometimes you have to deal with people who doesn't really understand technology. I remember somebody who wanted a guarantee that the price of the stock was identical in Tokyo and Sydney. And I chewed on this for a little while and said, you'll have to take that one up with Dr. Einstein, because you can't both have fast access and overcome the uh, speed of light. It takes time to shift information from Tokyo uh, to Sydney, or from somewhere halfway to both places. It's just difficult, and these are not computer science problems unless you really want to beat the speed of light. Um, we can't, but there are technical problems of doing the best possible in difficult situations. And as I said, I worked a lot with communication stuff, transmitting data from A to B. And there, bank and financial organizations have interesting problems. You need fast, reliable, and cheap. Get all three. It's difficult.
It is, very much is. And you mentioned something interesting about academia and education, because I've done some work in academia as well. Being a professor, created educational material, like exams at a university, some marking, etc. And yeah, like to try and get anything through and to try and change things there, like when people think of professors and academia, and especially, let's say, science, you think as the most forward thinking community that is open to any idea and would logically think through it. Whereas what I've experienced and what you see if you just watch a documentary on science, the amount of people you'll get, scientists, or especially celebrity scientists, not that they can't do the science, but they are celebrities as well in their own right now. They'll just say, this is absolute, this can't be done. And it's like the thing that you are calling basically fact 100 years ago was not considered to be correct, and 100 years before that what was correct wasn't correct, or wasn't considered to be fact. And that's definitely what I found with education, and I'm guessing you found that as well. Like, people in academia can be very, very stubborn.
Yeah, well, you have to remember that science has a lot to do with giving the best explanation we can, and then knowing that it's not perfect and having to change our mind as we go along. Some people don't understand that. They want it to be absolute truth forever and ever. That's just not the way science is. As I said, for engineering, feedback is essential. And in science, we get new experiments and we have to adjust the theories as we go along. You could say that Newton was wrong about gravity.
Hmm.
Well, he wasn't. He was just not precise enough and couldn't handle extreme cases. Einstein could do better. And
But
we've
I'm
just
sure.
managed to prove that gravity waves move at the speed of light. That was not easy.
Yeah, like, I know the example with Newton. Obviously, his science, his physics took us to the moon and back. Like, 150 years ago, that, or even 100 years ago, that wasn't even a thing. Like, that was like for most of human history, that was, if you said that to someone, for a big chunk of human history, they probably wouldn't even understand the concept of going there, or what that really is. And a huge
No,
chunk of
they
it would
could do
say,
it in fiction. They could do it in fiction where everything's easy.
yes, but not in real life. It was like, no, that can't be done. Like,
In
that was just,
science and engineering, you get all the details, you get all the problems, and you have to solve them.
Yeah, the that is the problem, and obviously, Newton's, you know, physics works for certain parameters. Einstein's works for a certain, and then there'll come a time where Einstein's just isn't enough, and you'll have to be something else. But a lot of people,
We'll see. We'll see. We'll see. We don't know. But yes, that's likely that there will
you
be some edge cases that needs to be dealt with. But it's likely that within the parameters that we knew, say in the 1930s, within those parameters, Einstein will probably stay correct, just the way Newton stayed correct till the late 1800s, till
yeah,
we found new cases.
yeah, of course, and it's
Anyway, I shouldn't be talking about this. I'm not a physicist. I'm a computer scientist and engineer.
I mean, is computer science not an extension of mathematics and physics in a way?
In some way. It's also its own, and yeah,
So you earlier on mentioned about keeping your foot into a bit into education, a bit into obviously some sort of work or projects. You're working at Columbia University, you're teaching there. I'm sure you're doing some research stuff there as well. Are you working on any like projects? Maybe with a company or some actual product as well at the side.
I'm not at this time. At this time, at the university, I'm just teaching, and most of the stuff that I do that could be considered research is in the context of the C++ development, C++ standard. I'm pushing some notions of safety, and I'm trying to get functional style pattern matching into C++, which would be a great boon for a lot of programmers.
So you're not doing anything outside of the university in terms of working on some sort of
Research.
application or
No,
project.
I'm not doing any blue sky research. It's more practical, more engineering like. The engineers always seem to like my work better than the pure scientists. Um, I mean, I'm a member of the National Academy of Engineering, and I got the Draper Award, which is the award given to somebody who's the best engineer of the year. So they seem to like what I'm doing, and what I'm doing now is sort of more engineering like than it's pure science.
Okay. And because you've been around in the computer science realm for many decades now, you've been a big part of it with C++ and your indirect involvements in other languages as well and influences. And then obviously you work at Columbia University. Somebody that's young, starting out in programming, always looking to you know go into some sort of computer science field. What would be your recommendation? I asked directly because my sister is at college or UK college, so not university yet. She's doing math, physics, and computer science. She wants to do computer science, some sort of programming at university. A bit of influence from me, there. But like, what sort of advice would you give to someone like that when they're starting out to
I
make
think
the most?
I mean I get questions like this reasonably often, so I have some kind of answer. You can't be too precise. One of the things is that we don't know the future. And so the first advice is don't be too sure you know what you need and what you want, because the world will have changed in a few years, and so will you. That the implication of that is that your education and your knowledge base should be broad, because if it's narrow, the world is likely to move out of that narrow space. So these days, everybody wants to be an AI expert,
Hmm.
learning LLMs. And in 5 years from now, my guess is there'll be a serious overproduction of that kind of experts. So it would be good to know something else. Um, Even if you do specialize in that, you should know some other field where you could apply it. You can't just be a computer scientist. You have to know how to compute something. So have a second field. Could be history, biology. I don't know what. Just something else than the data structures and languages. And then, secondly, be driven by projects, not theories. Theories are great when you know what you want to do, but they're not always a great thing to guide you to what to do. It's more once you know what you want to do, you can use it. Use theory and general education.
Yeah, I mean, I'll echo that. I agree. As somebody that went to university and did computer games programming as my, degree, I would recommend just going into regular computer science for most people. Get those fundamentals, have maybe in your personal time, experiment with a few areas in, let's say computer science, a few areas in programming, be that web, and then comparing that to games, and then regular sort of, let's say, mobile applications, or even iOS versus Android. Having a look at there, or back end, front end, whatever it might be, because you might discover that one, you like something that you didn't realize what you thought of, what you thought you were like, but two, you might actually be really good at it, but just because you had the sort of blinders on that, I just want to do game development.
Yeah, I think was it Pasteur that said fortune favors the prepared mind. That is, you have to be able to recognize an opportunity when it comes flying back by.
Yeah, there's another quote like that. I can't remember the exact quote, but it's about luck. Y- Everyone has some sort of luck thrown their way, but if you're not prepared to see when that luck comes your way and how to utilize, leverage that, then it doesn't matter. So sometimes being lucky literally is knowing when to leverage it. So, sometimes it just gets given to people. That's fair enough.
Yeah,
But even then, there's an element of, did they actually capitalize on it? Were they mentally prepared?
yeah. I think the quote is the harder I work, the luckier I get.
Yes, that's the one.
But that's only true if you're not over specialized.
Yes.
Or if, I mean, or you're lucky enough to be specialized in the particular field where there's something to be found.
Yeah, the having a broad set of skills and broad knowledge definitely helps, and especially at the start of your career. Don't, again, my recommendation, don't box yourself in too much. Obviously, if you have one or two areas of interest, fine, pursue them, and especially if you find it enjoyable and you find that you're good at it, that's great. Like, if you can figure that out, that's fantastic. But then don't close yourself off to the point where you just don't do anything else. Because it always reminds me, when I was at university, after second year, I did a placement year, and uh, most people uh, didn't get placements in games companies, video game companies, so in some sort of game development role. And I was the same. I worked at a consultancy company doing programming, but not games programming. I remember a couple of my friends who were studying with me, they said, if I don't get a computer placement at a computer games company doing working on some sort of video game, I'm just not gonna do the placement year. They didn't do the placement year. They went to final year. And the funny thing is, everyone that I know that said that, none of them are actually in a games company post university. They're working, they're doing well, but they're in a non-games environment. And I was like, what happened there?
Yep. As I said, you don't know what the future brings, and you don't know what you are like in the future.
Yeah.
Um, I've said this in some other interview and actually gotten hate mail for somebody claiming I was giving advice that was disastrous for young people, and that they really had to specialize early to survive. Oh well, so I think I'm right, but it's not an uncontroversial statement.
No, no, and as I get older and as I've gone through specialization and generalization, I 100% agree. And the problem is when you are the other thing is when you're young, and this is the case with anything outside of development as well. When you're younger, you can experiment and take those risks with little ramifications versus when you're 40 years old, you're in a job, let's say you're married, you have kids, you've got, bills to pay and you've got dependencies, then it's a little harder to say, you know what, I don't quite think web development was for me. Maybe it was working on games. It's a lot harder to make that shift and experiment when you're 40 versus 20.
Also, you have sort of you have a reputation that you have to maintain, so you
Yes.
can't easily go and become a novice and the new kid on the block that makes all the mistakes. That'll hurt more than if you're younger.
Yeah, yeah. Obviously, if you're older, plus if let's say you're a lead developer somewhere, the chances of you wanting to go become a junior developer with the remuneration that comes with a junior developer, just because you want to shift, is unlikely. So you do get sort of put on that path, and you get into that bubble of, this is everything that comes with the path that I've chosen is what I want. I don't want to make that shift anymore. So yeah, it does make it very difficult. So doing it at the start of your career or whilst you're still at university, experimenting and seeing what's out there, you really do figure out, or you get the opportunity to figure out what you really want to do. And it might even be a matter of you just don't care. Like, if it's industry or the type of development you're doing, you might just not care. Like, what actually excites you might not be, am I working in a video games company or not? It might be the type of work that you're doing. It might be the type of people you're working with. It might be, oh, especially in the modern world, is it remote or not? Like, there might be certain things outside of the
Lots
development.
of things, and also you may decide that games aren't actually doing that much for humankind, and you want to go into medicine or space research or something like that. What is it that you're doing for the world? Uh, Different people have very different opinions on that.
Yeah, and I feel like I wish, as an individual, I think you should think about it. But I wish at university that was discussed instead of just the technical aspect of your degree. Now, is it right for you? Because, person A and person B, their background, their upbringing, their sort of interests might be heavily different. So, them going down a certain path, like obviously, we're always told, you can do whatever you want, even if you can't, should you do whatever you want? Like, is that the best
A,
thing about the person?
a good professor is not totally neutral. You can't give advice that is not that is value free. You are trying to transmit values, and professors should know that. And some people do it very well, and some people try to shy away from it because it could be controversial. And the students may not want to hear exactly that version.
Yeah, and I think there's also the aspect of, regardless of what the students want to hear, the actual, let's say, academia in general or the institution might not want you to talk in a specific way or say this or that. They may want you to be very specific, with your sort of message. And then you think, okay, do I want to upset the establishment or not?
I don't know. I have no experience with that.
Okay. I mean, that's fair enough. I mean, if you, don't have that, I mean, that's good, because it means, you haven't had to, you haven't been in that situation where you haven't had to make that sort of decision. Moving on, briefly touched on it earlier. AI. Do you use any AI tools? Have you used any of the main ones out there like ChatGPT, Google Gemini, and what do you think of them with,
Not,
especially on the
not,
realm of development?
not really. Um, I'm sort of fully engaged in other things, so I haven't had time to become sort of more than a moderately well-informed layman in that field. And by the way, I think one of the most important things for an expert in some field is not to try and be an expert in every field. So I don't feel at all bad saying that I don't know that much about AI.
And
And
like,
as we said earlier, I'm a low tool user in general. So I'll probably be one of the later adopters of some of the tools related to my work that comes from AI.
yeah, because obviously, if you're focusing on tools or sort of a development workflow that doesn't have too many assists and tools that kind of fix you into a certain workflow, then yeah, AI definitely isn't going to graze it. It's going to be on the higher level side of things.
Also, what is the AI trained on? Um, I tend to do things that aren't done very much yet and experiment. And AIs are better at things that has been done a million times before because that you can train it for.
Yeah, obviously, yeah. Right now, especially when we don't have, artificial, general intelligence or anything like that, it is based on what it's already seen and trying to interpret it from that, or ideally, just spewing it, kind of like an advanced search engine with some, tailoring to it, instead of like you were saying, something that it's never seen before, maybe technologies that don't even exist and trying to figure that out.
Hmm.
So in terms of working at Columbia University, dealing with undergrads, dealing with obviously postgrads as well. What's your personal preference? Like, do you like that challenge of having someone that may not know much about computer science or programming in the undergrad, or do you like, teaching people that have already done a degree and have some basic knowledge?
I did some years of teaching freshmen when I was in Texas, and it's amusing how many of them think they know more than the professors. They come in from the high schools where they were usually the smartest kid in the class and quite often smarter than their teachers, and they come in knowing everything. So I dealt with that, and that was quite interesting. At Columbia, I don't do that. Usually, my students are either third, fourth year, or beginning postgrads. So I have no um, real knowledge about the freshmen here.
Fair enough. And again, going back to your work experience, you was at Bell slash AT&T Labs for 33 years, Morgan Stanley for 8, Texas University. Obviously, that's in a professor role, but still there for 22 years as well. Obviously,
No,
there's
no, no, no,
crossover.
no. You're making me 100 years old, and that's not
Okay, there's
true.
crossover. Obviously, there's
Uh,
naturally a
I
crossover.
think it was 24 or 5 years at Bell Labs. It was about 10 years at Texas A&M, about 10 years um, at Morgan Stanley. And then I've actually managed to be almost 10 years at Columbia. So obviously there's an overlap between Morgan Stanley and Columbia. And one of the things that Morgan Stanley did, which was unusual, which was they, we like to do some good for the community. So why don't you do some teaching at Columbia? So I was a visiting professor sponsored by Morgan Stanley. Now I just I don't have them paying my salary, but I'm still doing roughly the same thing. Um, so if you add up all of these years, you'll get almost 10 too many. But
So yeah, like as we wrap up the this episode of FireDEV, like my question was, obviously you've been at organizations for like some 2 decades plus, some a decade, some number of years. When we're in a world, especially right now, where it's not uncommon to have the X number of years of experience and then have
Mhm.
more than that in terms of actual different roles at different companies. What's your advice for people nowadays in terms of, should if they can get a long-standing position, is that still something you would recommend? And like, was there ever any point where you had to kind of, I wouldn't say convince yourself, to stay somewhere for a long time, but to kind of get you through? Like, did you ever have thoughts of, I've been here for 5 years. Is this still something I want to do? Then you've been here for 15 years. Is this still something that I, Bjarne Stroustrup, still want to do for this long? Or was it a matter of you're just happy to be here?
I was generally happy to be there. Bell Labs, AT&T, wasn't the same when I left as when I came. I had a good time. They were very unhappy to lose me, but it wasn't what it used to be, and it wasn't so much fun. And so I wanted to try academia, so I went to Texas. And at the end of Texas A&M, yeah, it was changing a bit. I would not have liked to be there today, but it was good while it lasted. And then turns out that my some of my family and my grandkids were in New York City, so I was sort of open to a move up here. But uh, I like to be in a stable situation for a long time. It may not suit everybody, but I have some fairly long-term project called C++, and um, that I can do just about anywhere. What matters is what other input I get into that. And teaching gives input, academic research gives input, industrial projects gives input, and the industrial places I've been at had tons of projects. I reckon that in the 80s, I probably helped on something like 10 projects a year. I wasn't just doing compiler writing and such. I had to learn something. And so you can get that change of roles or that input without actually moving company or moving house.
No, that that makes sense, and you can definitely still get a wide experience sometimes within the same organization, and it might be worth even speaking to the people there, especially if it's a long-standing organization. That okay, you want something different, but you like the confines of that organization. I'm sure if you
Yeah.
say that to someone,
This is by the way one reason I've been in big organizations because they have a variety of projects. Small
mm,
organizations are more focused, which is very good for a small organization, but maybe not what suits me from my attitudes.
yeah, and it also means that if you've been there for 10 years, I doubt they're keeping someone for that long because they think they're bad. Like they believe that you're good and you're delivering good work. Then I'm sure they want to retain you. So if you say,
Yeah.
I'm not quite enjoying this anymore, I want to try something else. When the opportunity comes along, can I jump onto another project? I'm sure they'll be like, yeah, that's fine. We'll talk through it. We'll work it out.
Yeah, I haven't worked for many places, but I've never left a place that didn't try and talk me into staying.
So it's a good position to be in. So before we wrap up, one of the things I always do with all my guests is like a rapid fire, I call it fun round of questions, not directly related to what you do. Are you up for that? It's more about like personal interests.
Okay, let's try.
Okay. So first one, favorite movie and favorite TV show,
Oh dear, I essentially never watch TV, so I don't have one.
including movies, so no movies.
It's a long time since I've seen a movie. We could pull out something like Casablanca.
Also, we're going back a fair bit then.
Fair bit, yes.
Okay. I mean, okay. So, what does Beyond like to do for fun? Is it just pure coding and C++ and research, or do you like other stuff as well?
Oh, I like other stuff as well. I like traveling. Um, I like meeting people. I like good meals. I like running so that I don't get too fat for the good meals.
Uh, and
I read a lot, not just technical.
what's your literature of choice, or like, what's the other sort of things do you like reading? Economics, philosophy, war books, or fiction?
No, what I was thinking about right now was actually the classical English mysteries, where people are murdered quietly off screen, and they're very good at going to sleep on because can't you have to calm down before you sleep.
Okay, and uh, I'd like to usually what I would ask next, like favorite video game. Are you into video games?
I was, but then they felt too much like work. You had to plan and think hard, and it was too similar to what I did for a living, so I stopped.
Pretty stuff. Okay, and if you didn't go into the field that you did, especially a technical field, was there something else growing up that you thought you know I want to do? Because I'm sure everyone growing up, they're like I want to be an astronaut, I want to do this, I want to do that. Was there something really that you felt like, oh, I would have loved to do?
I know what I was thinking about at the time: architecture, psychology, philosophy, history. I guess if I'd had a free choice, I might have become a historian. But I decided that history was a great hobby and a lousy career, whereas math was a lousy hobby and a great career. As you noticed, I was slightly wrong about that, but it led me in the right direction. I still read a lot of history.
So I mean, history is always nice to read, and I find if you really want to learn and read a wide variety of books, you end up dabbling in history inadvertently or directly anyway.
Yep.
So, final question, two-parter. Does money buy you happiness, and what does a good life mean to you?
Oh dear. Uh, Money doesn't buy happiness, but lack of money can buy misery. So you need enough. And I guess for different people, enough is different. Um, and what was the other half?
What does a good life mean to you?
Oh dear. Hanging out with nice people, having a nice family, having enough of what you need, travel a fair bit, and
That
making a contribution to the world.
positive impact. So, I mean, that's usually where I would end the podcast. But before we end it, because I know you mentioned travel, a few times. What's some of your favorite places that you've, traveled? And do you like a relaxing holiday where you go there, you stay at a resort, you just, relax and chill, by the swimming pool, or do you like to, go somewhere, visit historical sites, visit different restaurants, so what are some of your top go-to destinations and what like type of travel?
I'm not very good at just relaxing, so I'm not a beach person. I get bored very easily there. I like to go and see historical places. I like to see nice natural features like hiking and such. Um, when I talk about dining, I don't mean the fanciest food. I mean a nice meal with friends. so where you sit and talk about all kinds of things while getting good food. And I mean, I like to go to my native Denmark, which is a wonderful place, and Norway is great, France is great, Spain's great. I've had nice times in India. Um, I've been to China a few times. That's interesting, but not really top of my list just now. Um, yeah, that's. I'll be in Norway again in 3 weeks. I've had some nice visits to Poland, Turkey, yeah. Istanbul is very interesting. So some of the old classical places there, they have some amazing old cities.
It's on the list for me and my wife. Turkey in general, Istanbul, Cappadocia, and a few other places there.
Yeah, I haven't been to Cappadocia, but the old Greek cities on the coast are very interesting.
Yeah, I mean, from what I've seen on videos and pictures, it looks absolutely stunning and beautiful, especially when you do contrast it with something new like Dubai or Singapore, for example.
I don't
You know,
feel too attracted to those places. I've been to Singapore, not to Dubai, but that was work. It's the only place where they have. It's the only place where I have seen they have greenhouses that are air conditioned so that they can have cooler weather plants. If you get
that's.
too hot in Singapore, go to the greenhouses and cool down.
I mean, I'll take that as a tip. When when me and my wife and the family go to Singapore in the future. But I mean, that's the last thing I would have expected. Beyond Stroustrup to say, go to the greenhouse if you want to stay cool. But I guess that's just the
It,
way they do it in Singapore.
it surprised me.
Yeah, I mean, yeah, I mean, so some of these countries that have a lot of wow for money, they do all sorts of crazy things.
Yep.
They do. Okay, so that's it for today's episode of FireDEV Beyond. I want to thank you for coming in today and sitting with me for just over 2 hours. It was a delightful conversation. I remember being at uni. It just feels like yesterday I was at university learning C++. The lecturer was showing his presentation, and your face was like on slide 2 or 3, on it. So to be sitting here with you and talking about C++ and amongst many other things, what was an absolute pleasure.
Okay, and thanks for inviting me.
No problem at all, and I'd love to have you, on again as well. So, thanks for everyone else that tuned into this week's episode of FireDEV. I'll see you all next week. Take care. Bye.
Bye.